Okay, welcome everyone. This is session 5 of our RaCEEs course. Today I'm running the session with Andy, and we are going to talk about the analysis and the results of an economic evaluation. So we are really coming towards the end of our RaCEEs course. So this is the penultimate session. We'll have another session in a couple of weeks' time. And today we are going to mention on the results side of things. So we're going to talk about the analysis of an economic evaluation, how the costs and effectiveness sides come together, and how we try to interpret the results from a cost effectiveness analysis. And then we'll discuss the difference between base case and sensitivity subgroup analysis. So we'll go a bit more in detail around those concepts. In terms of where we are in relation to the writing up of the manuscript, we are now exhausted the method section. So thanks to your homework, we now all got all the information we need to write up the method section. So in particular, the attributes of an economic evaluation, which we cover in session 2, the cost data, which we cover in session 3, and the outcome data, which we covered in session 4. Now we're going to concentrate on the result side. So when we will write up the commentary together, we will try to summarize the results of the economic evaluation, the economic evaluations you've been working on. And we will try to summarize the results of the main analysis or any sensitivity analysis performed by the author. So today's session is all about that, trying to make sense, interpret the results of an economic evaluation. The aim, as I mentioned a couple of times already for today's session, is to understand and describe the results from the base case and sensitivity subgroup analysis. So we will spend a few minutes trying to define a base case analysis and sensitivity analysis. Then I will talk about effectiveness results, providing you with some examples, cost results, again with some examples, and then Andy will talk about the ICER, the incremental cost effectiveness ratio, and then he will also cover the willingness to pay threshold. And then Andy will also discuss the net monetary benefit, or NMB. And then I will briefly describe the cost effectiveness susceptibility curve. And then Andy and I will talk about common types of sensitivity analysis. So this is an overview of the typical results you will see in an economic evaluation. Now, your own paper might differ, might not have all these things. So we're trying to give you as much information as possible in order to try and interpret potential results from an economic evaluation that you will see in your own paper. Okay, this is the diagram you will be bored of looking at by now. So it's just the typical choice we have between the two alternatives with cost and consequences. So we looked at cost in session 3, we looked at outcomes in session 4, and now we're going to look at the cost effectiveness together. So we're going to try and make sense of this joint analysis between cost and effectiveness. And I will talk first about what we mean with base case analysis and then what we mean with sensitivity analysis. So a base case analysis, and I'll read the definition with you. The base case analysis is related to the results obtained from running an economic model with the most likely or preferred set of assumptions and input values. So this is the definition that tells you that when we run a base case analysis, we are looking at the average patient, basically. So what happens in terms of average cost, average effectiveness, and we try to make sense of the cost effectiveness for the average patient in our data set or in our sample. Sensitivity analysis, instead, with a sensitivity analysis, we are trying to understand how the results deviate from those of the base case analysis when input values and/or modeling assumptions are altered. So this is, as you can see, this is a bit different. So we are trying to move away from the average scenario. We're trying to understand what might happen in other portions, let's say, of our data set, if we are trying to change, for example, some values of our input. So that might be the costs or values of the effectiveness, the outcomes, what might happen to the results. And that is important because, of course, if you think about the base case analysis, as I mentioned a few seconds ago, we are looking at the average patient, but that's not going to be fully representative of all our patient population. So it's important to understand what might happen in other instances, in other scenarios. So if we were to change the cost, for example, if we have a patient that consume a lot of healthcare resources, for example, what might happen to our overall cost effectiveness results. At the same time, if we have patients, we are going to be responding better than average patient or worse than average patient to a treatment, that will have an implication on our cost effectiveness results. So it's important that we try to capture this uncertainty and try to handle this uncertainty. And that's what authors of the economic evaluations you're looking at have done in order to understand how the results deviate and what the implications are for the cost effectiveness analysis. All these definitions come from a glossary, which is a very, very good glossary of economic cost effectiveness terms. So if you want to have a look at the glossary, you got the link, and it's provided by the York Health Economic Consortium here. And this is a really good tool that you can use even beyond this course if you're ever unsure about what economic terms mean. Any questions? Okay, so I'm going to give you an example of what we mean with effectiveness results. So we are going to talk about clinical effectiveness and composite outcomes, which we saw in session 4. This is the article by Chalduri et al., which we are using as an exemplar for our examples throughout the course. And this is the article on advanced Parkinson's disease, which we use for our first ever RaCEEs. And you can see in this table, table 3, we got the base case results per patient over the model time horizon and the cost breakdown. And in particular, I would like to concentrate on the QALYs and the life years results. So these are the results on the effectiveness side. We saw the QALYs quite in depth last time in session 4 with Misael. We talked briefly about life years, which is another way to measure clinical effectiveness. And in particular, we're going to look at the results now for the LCIG group and for the standard of care group. LCIG means levodopa carbidopa intestinal gel, which is the treatment the authors were investigating or looking at in this particular advanced Parkinson's disease study. And you got the numbers here. So for the intervention group, let's say, you got 2.82 QALYs across the time horizon of the study. For the standard of care group, you got 1.43 QALYs. The difference is 1.39 in favor of the intervention group. So people in the intervention group seem to accrue more QALYs than people in the standard of care group. Similar results for the life years, where we see a higher number of life years gained in the intervention group compared with the standard of care group. And here the difference is 0.36 life years. So just looking at the effectiveness side, it seems that the intervention performed better than the standard of care. Okay? People seem to have more QALYs, more life years compared in the intervention group compared with the standard of care group. Now, let's have a look at the cost results. So we are trying to compare the intervention in terms of the total cost, and this is something we covered in session 3. So we're looking at the same table, but this time at the first row, which is all about the costs. Costs are expressed in pounds. So you can see the cost for the intervention group, the cost for the standard of care group, and there are higher for the intervention group. In particular, they're about £30,000 higher for the intervention group. So that means the intervention is associated with more costs, again, at the average level. So we're looking at the average for the average patient in this case. So there seems to be more costs with intervention rather than compared with a standard of care. And this is something we need to consider. Now, if we're looking at a cost effectiveness plan, which is something we presented in previous sessions, we are in this quadrant where the new treatment is more effective. So we saw that the new treatment is going to produce more QALYs, more life years. However you want to measure effectiveness, the new treatment seems to be more effective than the existing treatment or standard of care, but at the same time it's more costly. Okay, so we saw there are more costs associated with the treatment. So we are in this northeast quadrant, which is a bit of a gray area, trade-off area, where we have to consider, okay, there are higher costs, but higher effectiveness. How do we decide here? How do we interpret these cost effectiveness results? What kind of decisions we can make here in this situation? And Andy is now going to talk about how we make this decision using the incremental cost effectiveness ratio. So I'll stop sharing unless you got any questions, and I'll hand it over to Andy.
I'll just load up if I can. Do you have to give me permission?
Yeah, I know. This is definitely added today, this thing.
I know. It's gone off twice this morning.
Let's have a look.
Have
I'll
I
put
got
together a price.
if I got permission, Valerio, because nothing's coming up on my share.
I can see you start the screen share. Okay. Oh,
Nothing's coming up in the point of view from this available slides.
let me have a look. So you are a co-host already, yeah. Make host maybe. Yeah, let's try again.
If not, you might need to
Yeah.
come from your side.
Okay, maybe let's do that. Yeah, I'll share. That's fine.
Yes. For some reason, it's not bringing them up on my when I press the share.
Okay. No, that's fine. Okay.
Okay.
Okay. Yeah.
Great, thank you. So, as Valerio says, as we've been going through the different sessions, etc., we've been building up to the fact that we're looking at the difference between different interventions in terms of their costs and their benefits, their effects in that sense. And what we're doing is we're trying to do this from the point of view of people who are making decisions, whether that be a sort of more wider level of organisation for nationally to make decisions, clinicians, or individual people who want to understand or know more about which is the best option to take. But particularly, I guess this is from the point of view of those national decision makers there. So we need to find some way of representing that information, because as Valerio showed, you can show the benefit, incremental benefit between the different interventions and the incremental cost. But what does it really mean in terms of the cost benefit, cost utility of the two? So we're going to look at a couple of different measures for that. And the first one is the incremental cost effectiveness ratio, but we're also going to look at the incremental net benefit as well. Now, the increment, as it says on the slide, the incremental cost effectiveness ratio is basically the extra cost you get for every additional benefit that you get from comparing those two treatments. Between those two treatments, the new treatment and the previous usual care within that. And that gives a figure that can be interpreted in terms of which one is the best one to choose from that. You can use it from the point of view of QALYs or cost utility analysis, or something like life years gained for cost effectiveness analysis, what you get for one more QALY or one more life year gained for that particular cost within that. So you can see in this instance, both in terms of life years gained and QALYs. This is a treatment for cystic fibrosis, which has always proved a difficult condition to be able to find interventions to treat, but Orkambi was one of those new drug treatments, and there have been other ones subsequently that was analysed, and that provides 3.46 life years gained or 3.445 additional QALYs from the new treatment compared to usual care, but at a very high cost, an incremental cost of 570,000 pounds for each additional for each intervention that's given. So when you use the ISA, that produces, you effectively divide that total cost by incremental cost by the benefit, and so you get something around the 218,000 pounds per additional unit of benefit within that, which obviously seems like quite a lot, but what we need to understand is what is a good ISA, what is an ISA that's acceptable to whoever is funding the different interventions, and what is not a good use of money. And there are a number of thresholds that are used. Before I go on to that, though, I'll just show you why an ISA is. Could you do the next slide, please, Valerio? Why an ISA is useful. Now, we shouldn't. These are league tables which have been used in the past, but there are sort of health warnings on using them. But it gives you an idea of how it gives that opportunity for people to see an understanding of the difference between what the cost per QALY is for an intervention. So that usual thing of providing advice, preventative interventions is quite often more cost effective than other types of intervention, whether it be hemodialysis, neurosurgery, etc. So you can get a sense of it, of the different cost effectiveness ratios within those. There is, as I say, there is a health warning in using these, because obviously every intervention is used on a different type of population, and the analysis may have been done in a different way. So these tend not to be used, but this is just to give you an idea of what they are. So next slide, please. So we need to understand how to make those decisions about what is cost effective or not. And there are a number of different ways or different types of thresholds that are available out there, and they can be explicit and stated by the organisations in different countries, different jurisdictions, but they are quite often implicit, because that gives the opportunity for the decision makers to have some flexibility as to whether they recommend an intervention or not. To give you an idea, the World Health Organization's willingness to pay threshold is 1 to 3 times the country's GDP per capita per QALY. China has 0.5 to 1.5 GDP per QALY, but this is the one that on screen now on the slide is the cost per QALY that is used as the threshold for NICE, the National Institute for Health and Care Excellence in this country. It's recently changed due to a number of different factors, particularly around the issues associated with America putting pressure on the UK to increase its cost per QALY. So they have a threshold, willingness to pay threshold, that varies. So anything below £25,000 per QALY for a standard health intervention, not one that's associated with highly specialised technologies, is nearly always seen as being a good use of money, effective use of the NHS resources. £25,000 per QALY, above that, it's seen as being probably a reasonable use, but the decision is normally affected by a number of different factors, such as how uncertain the decision-making process is, the data that we use within the analysis, whether we've captured the benefits and other factors associated with health inequalities, and the highly specialised technologies, which are basically known as orphan drugs, where there's a very small number of people have that condition, and therefore they have increased the threshold to about £100,000 per QALY. Between 25 and 35,000 pounds per QALY, then there has to be a strong case made as to why that should be recommended as a treatment. There have been instances in history that NICE have recommended much higher cost per QALY and that comes down to other factors, such as whether it's what's known as a treatment of last resort, those sorts of factors. So this is an implicit sort of basis on which decisions are made, because it gives the committees a certain amount of latitude in being able to identify how uncertain the evidence is, whether it's an innovative technology, and taking into account wider societal costs. Go to the next slide, please, Valerio. So just to show you that this is what in Scotland, the SMC, Scottish Medicines Consortium, uses their basis for it. So they were aligned very much to NICE's cost per quality threshold, but they haven't changed their subsequent to NICE changing theirs to £25,000. So you can see that there's a certain amount of consistency around these, with certain variation around it, with the different thresholds that are used by them. Next slide, please, Valerio. Based on those cost per quality, NICE can make a number of different decisions around whether they support something or not, and they can fully support it, or they can partially support it for a number of different reasons, such as within specific populations, or if they feel that there's a need for additional data, additional research in the area, but they don't want to stop it being a particular intervention being used, because they want to collect more evidence to make a judgment about the certainty of that evidence within there. And then there's also not supported. And it gives them an opportunity for them to work with and negotiate with maybe the manufacturer pharmaceutical companies who may ask for a much higher, or ask for a higher price, which means the cost per quality isn't within the threshold. And then it gives an opportunity for them to gather more data to see whether it really is truly an effective use of resources. If we go on to the next slide, Valeria. However, ISAs have certain challenges around them. One of them is that you can get the same ISA for very different findings within it. So here you've got two comparisons. The top comparison shows that the new intervention is more costly and less effective than the standard intervention, and therefore the new intervention is dominated by the standard intervention. And it comes up with an ISA of -10 because of the cost difference. It's +20 and -2. But in comparison B, the new intervention is actually more effective and less costly than the standard intervention, with a -20 in cost and a +2, but it creates exactly the same ISA, but yet the new intervention dominates the standard intervention. So that makes it a slightly difficult situation for decision makers to make their decisions, if you can get in situations like that. Also, if you had the denominator was 0, you will obviously get an ISA that is infinity. So that's a really difficult situation to make a decision around it. So therefore, we tend to use something called the net benefit. Could you go to the next slide, please, Valeria? I think this just illustrates the fact of that previous example, that the two findings of the existing treatment dominating and the new treatment dominating means that they vary from the northwest to the southeast quadrant, which is obviously creates that difficulty associated with the decision making. Move on to the next slide. So another outcome that's used is the net monetary benefit, which is basically the incremental benefit. This is where we bring in the threshold into the calculation to try and overcome those problems. So it's the incremental benefit, and you multiply it by the willingness to pay threshold and take away the incremental cost associated with it, which, as you can see from the formula below, that definition there, it identifies that when you interpret it, a positive cost effectiveness is seen as being good. An incremental benefit that's positive is good, and a negative is bad from those instances. Going back to that or can be example, you can see here, I've just done The one in green is the one that actually NICE made their decision based on, and then I've just calculated again using the new threshold. So it makes very little difference, because you can see that it has a £600,000 negative £600,000 net monetary benefit associated with it. So in theory, your decision would be not to provide guidance to use that as a drug. Obviously, you then take into consideration the fact that it's cystic fibrosis and there aren't many treatments available, and therefore the actual finding was that it should be used in certain circumstances as part of research to try and understand more about how they can reduce the cost or increase the benefit associated with it. Okay, I think the next slide, please, Valeria. So this is a different example. This is to try and show how other challenges come about in looking at the two different forms, the ISA and the net monetary benefit. So this example is an assessment tool for dementia compared to the standard assessment process within it. And as you can see, the costs for this particular analysis were very large, but created an incremental cost per patient of minus 123 and a QALY gain of 0.016, so very small differences between them in that sense. So in theory, that suggests that the ISA identifies that the new tool dominates the standard care. However, when you calculate the net monetary benefit or the net health benefit, which is just a slight change, so that's the changing it to be the incremental benefit minus the incremental cost times the threshold, both of them are negative, which indicates that it's not a good use of money. And that's partly because of the fact of its very, very small differences between the two. So that creates a challenge for the decision makers as they then use other evidence, and that would probably be associated with what the quality, what the quality of the analysis was that may have created this situation within there, and therefore they would be considering how they then make their decision based on that. I think that's it, and over back to you, Valerio.
Well, thank you, Andy.
Thanks for doing the slides.
So, any questions? Okay. So Andy was describing the change in threshold, which actually happened a few months ago, and in the UK we moved from a 20 to 30,000 pound threshold to a 25 to 35,000 pound threshold per additional QALY. A way to handle a potential uncertainty around what the threshold might be is provided to us by trying to produce a cost effectiveness acceptability curve. So with this curve, which I'm going to show you an example now, we try to understand, okay, if there are different thresholds, how much our interpretation of the cost effectiveness results will change. In particular, we're trying to compare the willingness to pay threshold against the likelihood of the intervention being cost effective. So you can see this likelihood on the vertical axis and the willingness to pay threshold on the horizontal axis. In the middle here, you can see the cost effectiveness acceptability curve for the advanced Parkinson's disease study. So this is a figure we extracted directly from that study. And if you just look at the curve, you can see that it starts from about, let's say, 17% at the vertical axis. So it seems to me the vertical axis at the point where it's 17% probability. Now, that means that there is a 17% probability of the intervention being cost saving, okay? As you increase the threshold, the intervention becomes more and more cost effective. In a similar way, if you're going to supermarket, you got a higher budget, you are able to buy more and more things. So even the most expensive things will become cost effective in a way that they become worthwhile because you are able to pay for them. In this particular example, if we are going to put a couple of dots on the curve to reflect the cost effectiveness threshold in England, you got the first red dot, which is where the £25,000 mark is. So for that dot, we got a 45% probability of the intervention being cost effective. Instead, for the £35,000 mark, there is about 60% probability of the intervention being cost effective. And as I was saying before, you can see the likelihood of the intervention being cost effective has increased as the willingness to pay thresholds increases. So this is a way, again, that we can use to handle this uncertainty regarding the threshold. Of course, different countries, different jurisdiction might have different thresholds. Some of them might not be explicit, some of them might be implicit. So it's a good way to represent this uncertainty around the willingness to pay threshold. And this is just something that I wanted to talk about to introduce you to the concept of uncertainty. Now, I mentioned that at the very beginning today, where I was trying to delineate the difference between base case and sensitivity analysis, and I mentioned this difference between looking at the average patient and looking at other portion of your patient populations, what might happen outside the average scenario. Now, with the cost effectiveness and sensitivity curve, we're trying to understand the uncertainty around the threshold, but there are other parameters, other elements which might be affected by uncertainty. So it's important to understand that and to understand how we can interpret the results when we try to handle uncertainty regarding certain values or certain elements of our economic evaluations. There are different types of uncertainty, and Andy and I are going to cover some of them in the next few slides. In particular, we are talking about variability when we have unexplained differences between people in the sample, for example, genetic factors, which might not be observable. So in that sense, we might not know or might not be able to explain the differences because it's something that we cannot observe in the people in the sample. Heterogeneity instead refers to explainable differences between people in the sample. So the way people respond to treatment or they use healthcare resources might differ according to their age, gender, socio-demographic status, and so on and so on. So these are all things that are observable, could be included as part of our data. So we will be able to try and explain potential differences by looking at these variables. Parameter uncertainty instead is related to the impact of changing the value of certain parameters like cost, outcomes on the results. So if we change the cost of intervention by X amount of money, how will that impact on the results? And that could have implications, of course, and that could be also a realistic scenario because costs are likely to change in future, and they might decrease, they might increase. So it's good to have a look at potential uncertainty around the cost value. Similarly for outcomes, so it's good to move away from the average scenario and see, for example, how more severe people might be able to respond to a certain treatment, or less severe people might also be able to respond differently to a certain treatment. So this variation in the way we're looking at cost and outcomes might have an implication on the cost effectiveness results. Another type of uncertainty is structural uncertainty, which means trying to understand the impact of changing the model assumptions on the results. For example, if we were to change the type of model, we saw with Luis in session 2 the different modeling techniques which we can use, moving from a decision tree to a Markov model, or to a discrete event simulation and so on. What if we exclude certain comparators? We might have data that allows us to include other comparators in our study, or what if we exclude certain comparators, how we will interpret the cost effectiveness results in those scenarios. Similarly, for health states, there might be a different way we can model health states and try to characterize the clinical pathways of patients. So this is just an overview of the types of uncertainty that researchers, health economists will try to handle in economic evaluations. And I think now is your part, Andy.
It is, thank you. So yeah, as Valerio says, there are different approaches to doing this. Deterministic sensitivity analysis is probably one of the more simple approaches to it all, where you can you're looking to see how robust, how sensitive the results are to changes in either one or more parameters within the model. So changing a particularly favourite one is to see if you could reduce the cost. Which is put forward to some of the manufacturers, etc. If you reduce the cost, what effect it would have on the ISA, the net benefit within that. But you can also do scenario analysis where you change a number of assumptions or values or threshold, find the point at which a decision that would be made would change, which refers back to that, changing potentially whether it's the cost or the actual benefit, what you'd need to achieve in terms of benefit for it to make it a cost-effective option within that. Often you do this by changing different values in a pre-specified way, so that you're not just sort of cherry-picking things. So it's often usually a 10%, 20% change maybe, or using the confidence intervals as a basis for doing that. The limitation is that it's just focusing on the mean and ignoring other parameter uncertainty within that and the precision of the estimates, which Valerio will talk about after I've finished within that. So it's often the starting point for a lot of analyses to find out how robust they are within that. Next slide, please, Valerio. So ways of demonstrating which variables are the most important, which ones are driving, in particular driving a model, say, is to produce what's known as a tornado plot. And this particular one comes from one of those earlier examples. We talked about the integrated cognitive assessment tool for dementia. So this shows you which are the most important, and effectively it's the length of the lines within this that show the longer they are, the more effect they have in changing the ISA, the net monetary benefit within that. So you can see the ones at the top here are much wider than those at the bottom. So you'd identify those as being the key drivers of the cost effectiveness value. And I've just got one more example next. So here's another one, which is for a different analysis, which was for a drug treatment for helping to treat infections in adults. And again, you can see where the main drivers are here at the very top. So those are the ones you would focus on because they're the ones that can have the possibility of changing the result and have that sort of level of uncertainty around them, whereas the ones at the bottom are less so. Thank you.
Thank you, Andy. So Andy was talking about deterministic sensitivity analysis as a very good starting point to develop a further, more sophisticated sensitivity analysis. The next step will be to run a probabilistic sensitivity analysis, and you might see an example of these in your own papers. So a probabilistic sensitivity analysis, or PSA, is based on the distribution of the parameters. Here we go. So I'm going to use this set of figures here to try to describe what we mean with a probabilistic sensitivity analysis. In this example, we got figure 2 from this specific paper, where we have the cost and quality distribution for APBI alone, AI alone, and combination therapy. Now, let's not focus too much on the acronyms. Let's just think about the figures and what they're trying to represent here. So, for example, in this figure here, the figure A, you got the distribution of the costs. So that means you got different patients in our sample which are associated with different costs. As I was mentioning before, some patients might consume more healthcare resources, some patients might consume less. the higher is the bar, the more representative or the more likely is that you find a patient which consume that amount of healthcare resource uses, sorry, and so it's more likely to find patient with that specific cost attached to them. Of course, you see other bars which are particularly high, so that means again you got high likelihood to find patients which are associated with these specific costs. So going back to what I was saying before around the difference between base case and sensitivity analysis, the base case will look at the average, which is probably this one in this case. So you got an average cost, and the base case analysis will just focus on that. But you can see there are plausible costs which are not covered by the average scenario, which are very much realistic. So it's important to understand how the cost effectiveness results will change if we take into consideration this cost specifically, or this cost, or this cost, and this cost. So there is a set of plausible values for costs which are important to take into account. Of course, there might be some extreme values like here, which are quite unlikely, implausible. So they will be probably not so realistic, but at the same time, as I mentioned before, there are some other values for costs which are important to take into account because they're very much plausible and they could be reflecting what might happen in the real world. Similarly for the QALYs, you might have an average QALYs for the average patient somewhere there in the middle, but you can see there are a lot of high bars here which reflect different values of plausible QALYs which we might observe in our patient population. So it's important to take that into account as well. And this is what we do with a probabilistic sensitivity analysis. We try in a way to assign a likelihood value to a specific QALY or cost value. And we try to do a random draw of these plausible values, repeat that draw several times, and try to understand how our cost effectiveness results might change according to the different cost and QALYs value we extract from these distributions. So from a mathematical point of view, it's quite a sophisticated technique, but from an interpretation point of view, this is what we do. We're looking beyond the average level. We're looking at other plausible values for cost and QALYs, which could be realistic, and we have to take them into account. Similar interpretation goes for the other figures. So you got the cost for AI alone here, the QALYs for AI alone, and the combined scenarios here. So again, you can see there are some average values and some other values which could be still plausible and realistic. So it's important to take them into account. So once you perform this random draw of plausible values several times, you end up with a figure which is like this. So I'm sure some of the economic evaluations you're looking at will have a similar figures. This is a cost effectiveness plane with several cost effectiveness pairs displayed here. All these blue dots represent an individual cost effectiveness pair or joint cost effectiveness pair. And these pairs all come from a random draw of plausible cost and QALYs values. And if you try to display them on a cost effectiveness plane, you see that they tend to be, or the majority tend to be in the northeast quadrant. So here we are again talking about our advanced Parkinson's disease study. And it seems to be that even when we replicate this random draw several times, we take into account different cost effectiveness pairs, we're still observing the majority of the cost effectiveness pair lying in the northeast quadrant. So in a way, the sensitivity analysis here is telling us similar things to the base case analysis. If you remember the base case analysis, we had this trade-off between cost and QALYs, where the new intervention was more expensive, but at the same time more effective. And the probabilistic sensitivity analysis seems to corroborate that by saying, yes, actually, if we take a random draw of plausible values for cost and qualis, the majority of these pairs will land on or will lie on the northeast quadrant. But it's important to notice there is a minority, maybe not negligible minority of pairs which lie in the southeast quadrant, where the new intervention is actually less effective sorry, is more effective and less costly. I don't know if you got a question. A question from Jane, very good question. Yeah, how do you judge where a value stops being plausible? So if I can go back with my slide, here we go. So you use, let's say, software or mathematical formula which allow you to allocate a specific percentage to a specific cost and quality value, so that you know that, for example, there might be, for example, for this case, there 20% of this cost value to be likely or probable. So this is you can see this here. If you move across to the vertical axis here, you're just about 20% or just below 20%. Other values will be allocated a lower probability. For example, these values here, they seem quite extreme, and some of them are near 0%. So there is a way to take into account that these are the most likely values, and these are the most unlikely values. So these values will be drawn less compared with these values here, if you see what I mean. It's more likely to draw this value compared with these ones. Is that clear enough? Okay. So hopefully that's clear. I'll go back to my next slide. So as I was saying before, most of cost effectiveness pairs lie in the northeast quadrant, where the intervention LCIG is associated with higher cost and greater quality gain. But results also fall within the southeast quadrant, where the intervention is actually cost saving. So this is just to repeat the interpretation I was trying to formulate before. Lastly, I just want to show you the example from our first RaCEEs. So we were trying to write up the info on the analysis and the results from the advanced Parkinson's disease study. So in our results section, we had specific paragraphs talking about the base case analysis, the incremental cost effectiveness ratio, the cost effectiveness acceptability curve, the deterministic one-way sensitivity analysis, scenario analysis, and probabilistic sensitivity analysis. So we try to extract all this info from the paper and try to concisely summarize in an objective way the different elements of the analysis. And I'm not going to read the text in full, but you can have a look in your own time at the way we try to summarize all these elements. Any questions? Okay, so session 5 homework. This time the homework is a bit different. So we are going to ask you to think about 3 questions on the interpretation of the results from your own paper. So I try to extract the tables and the figures from each paper, and I've asked you to try to interpret the results based on the tables, the base case, the analysis, or the figures representing the sensitivity analysis. So looking at the slides from today's session, you can try and have a go at interpreting the different results from your own economic evaluation paper. Again, you got a couple of weeks to complete this homework just before our next session, which will be our last on Monday, the 27th of July. You can find the homework document as usual on Teams. So if you click on session 5, analysis and results, you will see a document with your own name. And then if you open that document, you will see 3 questions around the results of the economic evaluation you've been working on. And this is, again, the usual recap of where we are at in terms of the progress of the course. So next one will be our last online session, we will cover what we need to include in the introduction section of our commentary. That will be a fairly quick overview of what we need to include. And then you can bring some questions or any of the sessions or any of the elements we covered during the course. So there will be a moment for Q&A. So if you want to ask us any questions, just let us know in advance or just ask us during the session, and we'll try to cover that. And then we will talk about what will happen at the workshop, which will be in September. So we'll talk a few minutes around what to expect at the workshop during our last session in a couple of weeks' time. And that's all from us. I just want to thank you everyone for attending today, and thank you, Andy, for running the session with me. And we'll see all of you in a couple of weeks' time. Thank you.
Thank you.
Thanks, Valerio.